There are expressions that allow the Python interpreter to skip evaluating some sub-expressions. Let's take a quick look at examples of those. The logical operators AND and OR exhibit a behavior called short-circuiting. Here's how you evaluate some expression and some other expression, where we'll call them left and right, but these are just placeholders. You evaluate the sub-expression to the left of AND. If it's a false value, then the whole expression evaluates to that false value. Otherwise, you evaluate the expression on the right, and the whole expression has the value of the right expression. So if this is false, the whole thing is false. If this is true and this is false, the whole thing is false. If this is true and this is true, then the whole thing is true. And these values need not be just true and false, but they could be any values in Python, because every Python value is either a true value or a false value. So 2 and 3 would evaluate to 3 according to this evaluation rule. Evaluating some expression or some other expression is similar. Evaluate the sub-expression to the left. If it's a true value, then you know the whole disjunction is true, and so you're done. The whole expression just evaluates to v. Otherwise, you evaluate this expression on the right, and that's the value of the whole expression. Why is this useful? Let's look at a couple of examples. Let's say I want to write a function has big square root that tells me whether some x has a really large square root. Return the square root of x is greater than 10. I chose 10 arbitrarily, but that's just because I want a simple example. Now let's say this is part of the program where I'm interested in the real parts of square roots. So I don't want this to crash if x is a negative number. I just want to know whether the real part of the square root of x is big. I could write x is greater than 0 and square root of x is greater than 10. When I run this code, has big square root tells me that 1 does not, 1,000 does, and negative 1,000 does not, because its real part of its square root is 0, and the important part is that this didn't crash, even though I have an expression whose sub-expression takes the square root of a negative number. This never gets evaluated because of the way AND works. Once it's figured out that x is not bigger than 0, it's done evaluating the whole AND expression. Let's do an example with OR. You can divide. You can even divide a really big number. But if a number gets too big, then you can't divide 1 by it anymore. So 10 times 100 isn't that big. But 10 to the 100th power, now that's getting big. But it's still not too big. I could divide 1 by that. But what about 10 to the 1,000th power? That's a really, really big number, and I can't divide 1 by that without just getting 0 and losing all of the precision of what's really going on. It should be a decimal point with 1,000 zeros and then a 1, but Python doesn't work that way. As do most other programming languages, there's only so small a number that you can represent without it being rounded to 0. So let's say I have a definition of whether some number is reasonable, meaning it's not so big that you can't divide 1 by it and still get a non-zero number. Well, I could just say, is it the case that 1 divided by n is not equal to 0? But this will crash if I pass n equals 0. And 0 is a perfectly reasonable number. It's just not something that I can run this particular test on. So I might write that n is reasonable if n equals 0, or if 1 over n is not 0, meaning it's not so big that it gets rounded off to 0. So here, is 0 reasonable? Well, sure. And 10 is reasonable. And, this big number is still reasonable. The only unreasonable numbers are when I exponentiate and get 10 to the 10,000th power. That's just like a ridiculous number, not a reasonable number. And the important thing is that none of these crashed, including this one. We passed in n is 0. We didn't compute 1 divided by n because we checked this first, and since this was true, the whole expression was true. And that's why This short-circuiting behavior, which is a form of control, is useful in Python and exists in many other programming languages as well.